My name is Snively, so I'm a specialist SA that focuses on the analytical and machine learning services. I've been at AWS for about 4.5 years, working with customers really around the globe, using ML for all types of different workloads. In this session, we're really going to be focusing on some of the newer services we announced at re:Invent, and really demonstrating some of the solutions that you could build using those services. So rather than just showing you service by service, we're actually going to introduce some of the services and then show you some solutions on my laptop here, really hitting the cloud, but showing some solutions that you could use building as building blocks of that solution. So I do want to do a special call out for some of the other sessions that are coming up. There's a lot of good ones in the ML space. The last one's actually misnamed there. It's IoT ML a session, but there's a lot of really great sessions. So this session is going to focus more on the API AI-driven services. Pedro's going to go into SageMaker, and then there's a lot of other sessions following on that. So definitely worth sticking around. A lot of great sessions on the ML space here coming up. So in this session, though, we're going to be focusing on our Amazon AI services. And really what that means are these are API-driven services that are powered by machine learning and deep learning. And you don't really have to be an expert in those domains to use these services. They're constantly improving, and you could very easily interact with them through a set of API calls. And we're going to really demonstrate this, showing some code and showing some solutions that we built with about 130 lines of code, end-to-end document indexing solution, for an example. So if you actually look at our different tiers, and there's different representations of this, but they all kind of have this format. So at the very highest level, we have these AI services. And these do things like vision processing, video, imagery, text extraction out of scanned documents, those sorts of things. Also speech analysis, so not only text-to-speech and speech-to-text, but also understanding what's being said, natural language processing. And also being able to do forecasting, recommendation, personalization, those sorts of things. At the lower tiers, we're not going to really dive into this in this session, but these are the tiers where data scientists, data engineers, folks are really building very, very powerful models using their own data, deploying them out very, very easily with SageMaker, and being able to get that to production. But we're really going to stay at this high level in this session here. So we're going to start off with Textract. So Textract really allows you to take scanned content and extract information from it. And I like to call it a little bit more than OCR, because a lot of folks, when they think of OCR, optical character recognition, they're really thinking about being able to extract characters or words from documents. But Textract does more than that. It actually extracts information. It extracts things like key value pairs out of form data. It extracts table information if you have tables in your documents. So it's not only getting the words, but it's getting the organization and the construct of the document, which then you could bring into your system. And we're going to demonstrate this here in a moment. But what's really interesting if you're new in the space is if you look at scanned documents and forms and these sorts of things, oftentimes there's different variations of a form, and each of these different variations have the same information on the form, but none of the pixels are actually the same on any of these forms. So this is actually a really hard problem once you start trying to analyze and pull out fields out of a form. It's not just, these pixels are always representing these key value pairs across all the forms that you might have in your organization, in your government, in your customer space. And that's where Textract is really coming in to help. So as I mentioned, it's able to perform text extraction, but you're also able to get table information out and form extraction. We're going to step through each of these. So when it does text extraction, it doesn't have to have a document that just has all text. So in this example, you'll notice there's two columns. A lot of times in research papers, you'll see this sort of format as well. And what happens is when the service is processing the document, you get the information back about what page, what column, where that information landed within that document. And that comes in the form of these block types. And as we're kind of stepping through the code, you'll see examples of block type key value pair for form data, block type table for the table information. So the construct that comes back out of the service are these block types. And these block types allow you to iterate over that scanned document to be able to get that content out of that document. Just like that with table extraction, and we're going to step through a couple demos here in a moment, but you get the table information and the cell information. So what header was this column under for this particular row? Not just, is it this word at this location? And following the same syntax, there's a common return object with these block types, and you have the cell information, the table information, and what pages those tables were represented on. And then lastly, the form information. And with form information, it's really interesting because when you fill out forms, oftentimes you might have the form header at the very left, first name Ben. It might be underneath signature, right? And then it might have a signature above it. It might be, above it. So actually, the field name might fall in many different locations depending on the form that you're working with. And when you're processing the form data through Textract, you end up getting these key value pairs as well. So rather than just talk a lot about presentations and show a lot of PowerPoint, we're actually going to give some live demonstrations here. And what this demonstration represents is building a document index system. And what we're doing in this demonstration is, again, in about 130 lines of code, and we'll step through what this looks like. We've actually built this end-to-end pipeline that allows anytime a scanned document to show up on S3. It automatically triggers OCR and the different sorts of processing on that data. Then it performs natural language processing to drive the insights out of that document to understand what that document is being described. And all of that information gets stored into an Elasticsearch cluster for us. And then you could have your application query the data. You could have Kibana dashboards and have aggregated information in that. So all this flow really integrates really nicely as you want to build these different systems. So we're actually going to switch over to a demonstration here now. And so we're going to start off by having an S3 location. So this is actually various documents, and I should say this is all synthetic data. So if you see people's name, I actually used a tool called Faker and these different tools to generate the synthetic data. So none of this information are real people, those sorts of things. But I want to demonstrate what type of things you could do with the system. So I'm actually going to upload a new new document into this S3 bucket to trigger some processing. And I happen to be doing it just from a client I have running here. But this could have been from any sort of scanning software or any system. Or it could be from a mobile app, somebody taking a picture of a document and wanting to understand what's in the document. So I happen to be uploading it just from this machine. But this could have hit S3 many, many different ways. It doesn't have to be from this machine. And just to show this is all happening, so I just uploaded this. And you'll notice this demo document that just showed up here. And if we take a look at this document, this is the document that we're going to be processing in addition to all the other information we're processing. So a couple things you'll notice, oftentimes documents aren't completely vertical. It's very, very common for scan documents to have filter noise, orientation differences, that sort of thing. The other thing is you'll notice things like key value pairs at the very top and other information in here. So this is the document that we're going to be processing. And just to show what Textract is doing, so I'm going to be showing the code that does this, but I want to step through the console and really demonstrate how you could use the console and see what types of results you would get with your data, even without writing code. So here, this is the actual document, and you'll notice all the different terms that have been extracted out in the various lines here. We can actually look at it per word instead, that sort of thing, obviously. But I also like to show this. So what the service did is it recognized the field name was underneath the field value in this case. It may not always be the case, but in this case, the field value was underneath. And also, the date of birth is December 13th, 1912. The date of visit, that sort of information. These are all key value pairs now. So you could have this in your glue code. It could be an AWS glue or one of our partner ETLs or Lambda or whatever glue code that you have. And you could then take this information and store it into a NoSQL database or a relational database or that sort of thing. So this really lets you starting to build that index to be able to start processing this information. What's really interesting, though, is if you have table information. I didn't happen to have table information in that example, but I just wanted to show an example. If you have table information, you also get the table columns. You get the various rows and what headings they're in. So it preserves that document orientation of where that information came from. The next thing that we're going to do is we're actually going to run it through natural language processing. So this is actually text from the document. And what you'll notice is through natural language processing, it's identifying key phrases. within this information. So no history, recent, emergency room last evening. All these key phrases, and then also all the entities. So, for example, a date of 2 days ago. Technically, that's a date, right? 2 days ago from whenever this was written. So all these entities become additional metadata using machine learning, deep learning services that could then power your system, power your application, your document system, that sort of thing. Since this is a medical document, keep in mind a fake one, realistic but fake, we actually also ran it through Comprehend Medical. And the reason I like to show this is Comprehend Medical is very, very high fidelity data trained on medical data. And you'll notice not only does it identify medical terms like a diagnosis name of ab pain, how often has that ab pain been there? It's been very persistent. It also recognizes relationships. So, for example, this particular brand name was actually delivered through this means. So, for example, taken through the mouth, that sort of thing. So, all the relationships within the medical information are actually preserved in there as well to help you understand the context of that term. So, what does this look like within the code itself? I used to be a software engineer. I love coding, so I tend to always gravitate towards showing code, but I want to give some context of what the code is doing through the consoles first. So if we take a look at this, this is the code. This is the entire code base for this demonstration that I'm showing you. So if you think about AWS, our different services, the whole undifferentiated heavy lifting, all the other services are being provided for me. All I'm doing is providing this code, and then it's using Firehose to get the data into Elasticsearch. It's using S3 event triggers, and all that's being managed for me. Very, very low barrier to set up these sorts of demonstrations and capabilities. And just to show what these API services look like when you call them, these 2 lines of code here are really the 2 lines of code that I need to call to actually do entity extraction. And this is why we say these are API-driven AI services. You don't have to be deep learning experts, machine learning experts to use these capabilities. You're using them through APIs. You can do some things like custom training. So even though it's API-driven, for things like Comprehend, you could train your own entity types. For things like Forecast, which we're going to demonstrate here in a moment, you could train on your own data, build your own forecast models, that sort of thing. So even though they're API-driven, doesn't mean they're completely static. You still customize them depending on what your scenario is. But it's very, very easy to do it through these APIs or through the console, that sort of thing. I won't step through the rest of the code. I'm very, very tempted, but I won't necessarily step through because I only have 24 minutes left. And really want to show what the result of all this is. So if we actually take a look at the code here, we happen to be using a Firehose here. And the reason I use Firehose, it's really, really easy to use Firehose and send this data to a data system. That data system might be a data lake. It might be a data warehouse like Redshift. It might be Elasticsearch. It might be a wide number of different things. So rather than coding where I'm sending the data to, I'm using this as a way of streaming the results as I'm getting them to whatever content system that Firehose is connected to. And this Firehose happens to be connected to an Elasticsearch cluster that we have running here. So if we take a look at this Elasticsearch cluster, I'm going to actually launch into a Kibana dashboard. And this Kibana dashboard really lets you start looking at the data, slicing and dicing the data, start really processing, going through the different data sets here. And what we're going to really show here is, if might have a connection issue. Oh, we could. Oh, 1 second. Oh. Here, let me. Should I switch over to the Wi-Fi? Okay. I'll show that in a moment, actually. I'll go back to this tab here. So let's actually switch over to, I'll show this in a moment. Looks like I have actually a connectivity issue here. and let's actually switch back and talk a little bit about Personalize, and then I'll switch back over to here. Okay. We'll definitely step through some of this here. Or maybe my Mac's just not unhappy. So if we actually switch back to the just these screens aren't switched. Okay, sorry. Back to the demo here. We'll go back and show the Elasticsearch in a moment, but want to also step through Personalize. So Personalize does a lot more than just build a recommendation engine. It actually lets you build personalized content. And what I mean by that is you can actually personalize search terms. You can find items that are similar to each other. So it's not just a recommendation engine. It really lets you do different types of personalization. And the way it does that is it really lets you build these high quality recommendations. And it does this through automatic machine learning to be able to pick the right machine learning algorithm based on your data. And we'll step through an example of that here in a moment. It also lets you build a real-time pipeline. So you're able to feed real-time information into the service, and it will use that information in the solution that you build. And it's really powered by a set of both deep learning and machine learning algorithms under the covers. Different deep learning algorithms such as a hierarchical recurrent neural network and deep factorization machine and those sorts of things. And the process to really use Personalize is first you load your data into the service and then are able to inspect and select particular features. One of the key things about the service is we'll recommend hyperparameters. Hyperparameters are parameters that go into building your model, but you could also customize those. So even though it's an API-driven service, you could really customize the hyperparameters and the different elements going into your model build process the way you see fit there. And then after you train the model, you're able to deploy out an endpoint. And this endpoint could be then integrated with your cloud-native applications or really your other applications. Or you could also take that endpoint and do batch forecast or batch personalization on that data. And these are just some of the recipes that we call them, really algorithms under the covers that you could use within Personalize. And you notice, many of them have deep learning roots within there. The other thing that you could do is you could also do things like hyperparameter optimization or automatic model tuning. What this will do is it'll actually take the different models, adjust the parameters to really optimize them to make a really good model to a great model, just by tweaking some of the parameters that are in the hyperparameters being passed into those models. So just like in SageMaker, you do a hyperparameter optimization, Personalize and Forecast both have these features as you're building the model to be able to improve the model. And the way the data flow really works is you have various offline data sets. This might be user interaction data. It might be user metadata. So, if you talk about like the cold start problems, a lot of this other metadata helps with the cold starts because you could find similar users, similar items, that sort of thing. But it also has that real-time interface going into the Personalized service to be able to have that customization based on your application. And what we're going to be showing here is being able to use a browser application and be able to use that to call, send real-time events to Personalize. And then what's going to happen is as the application is getting recommendations, it's using both that model information that I originally trained on, as well as the real-time information that's been streamed into it, to then personalize that experience for that user. And then recommendations come back ultimately here. So let's go ahead and switch back. Hopefully internet's behaving now. So I'm going to switch over here. Okay. So this is the personalized interface. What you'll notice is the first thing is that there's these cluster groups. These cluster groups allow you to really have groups of data sets. And then each of the data sets allow you to have event ingest elements. So that event ingest SDK is optional. You don't have to have streaming events if you don't have that for your use case, but that's where that it gets flowed in. And then you could create a solution and then launch a campaign. And in order to really show the service and how it works, let me actually just first show a solution built on Personalize today. So this is a demonstration that we built pretty quickly to be able to show how you could do recommendations, customizations, personalization. And what we have here is I just picked a random user, and this is using the movie lens dataset, and then using personalization to customize the experience. And these are various movies that this particular user has ranked. And then you see other metadata. So this metadata is really important when you're building those models to help have that high fidelity model. And then what we could do is we could actually then go in here and say, let's go ahead and look at the recommendations for this user. So this is one type of personalization. What recommendations are for this user? What if you wanted to do instead a similar item type of question? So that's a different type of recommendation. Given this item, what are similar items? So what we could do here is we could actually say, given this movie, what are other movies that most other people like to watch if they've already seen this movie? So it's a slightly different twist in terms of how you're personalizing the content. And when you're building the model and the service, I'll highlight things like user personalization or search personalization, item similarity, and you could tweak which models you use based on what use case that you have within the service, how you want to personalize that content. So let's go back over here and look at the data set really quickly. And just to show here, so this is some of the data that is being used. So you see user ID, age, gender, occupation. All this becomes useful metadata for a lot of the models that get built. So, and this could be whatever domain data that you have. So it doesn't have to match this data, obviously. The service is going to use what data that you provide it within the schema. There's certain set fields, like user ID is a set field. So it's looking for set fields. And then any additional data that you have, you could bring in and it'll use that as metadata to help build a better model. So let's go ahead and take a look at one other element here. And it's a feature that allows you to do things like set up multiple recipes. So what if you have a situation where you don't know which model to use? There's many different recipes, algorithms under the covers within the service. And how do you know which one to pick, right? What the service allows you to do is once you bring your data into the service, you could then have it pick the right service for the right for your data set using this automatic selection feature. And what it will do under the covers is if we actually you could specify the different algorithms that you want it to select between, and then here's some of the sample algorithms. So you'll notice things like related items, that's item similarity, or search personalization or user personalization. So these are all different types of the personalization categories that I was referring to earlier that you could build within the service. You'll also notice like the cold start one. That's actually a hierarchical recurrent neural network that is really optimized for cold starts. It uses a lot of that other item metadata to improve the cold start problem when it's building those recommendations for that user. And then ultimately, you can actually deploy these campaigns. And these campaigns are actually what the service is using under the covers to be able to figure out what movies were originally showed on that web page. So I didn't really have to build my own models. It's really hitting these endpoints. That web page that we just showed a moment ago are essentially hitting the different endpoints for the different types of recommendations that it's building. So next, let's go ahead and switch back to the slide deck, and we're going to talk a little bit more about time series forecasting now. So this is one of the third service that we're going to discuss today, and we're going to also step through a set of demonstrations just to show how the service is really working under the covers after setting the stage here. So just like Personalize, Amazon Forecast is a AI service. It's API driven, it's console driven. You don't have to have the deep ML or deep learning experience, and it's really built on decades of experience that Amazon has been using to build forecasting of inventory, financial forecasting, workforce capacity forecasting, all types of different forecast domains that we've actually put in the service to have customers use. And then as customers are using it, obviously we're iterating on it, improving it based on all the customer feedback as well. And the really powerful thing about that, there's two key issues with time series forecasting. One of them is if you have a lot of different time series data sets, and if those data sets are sparsely populated, how do you handle null fields within the data set? That's a key problem that a lot of customers face. The service will handle that for you. It will actually find correlated relationships. For example, if I'm in the retail space, as the number of iPads that get sold go up, usually the number of iPad cases go up as well, right? Those are related time series. If I fly a lot, if I'm actually predicting how many flights are going to be delayed from airports, weather information oftentimes impacts that. So all this other metadata is brought into the service if you have it to be able to build those models. The other thing is you can also bring in your own dates. For example, Prime Now obviously is a key date for Amazon. So when we're doing forecasting, there's big spikes as Prime Day is happening. So these are different events or holidays that you could bring into the service to have the service know about key events as it's building those forecast models. And the other aspect is it really handles spiky data really, really well. We're actually going to be showing an example using the service of predicting electricity usage. And depending on the client, we're going to step through a few clients within the data set. Some of the clients have very, very spiky workloads, other ones don't. And it will show how the service has predicted those different clients and which ones have spiky behavior. And just like within Personalize, there's a lot similar steps as you're using the service. So first you load the data, you are able to inspect the data, identify these different features, select the algorithm. If you don't know which algorithm you want to use, there's an auto select process as well that lets it pick the right algorithm based on your data set. And then be able to train and deploy these models. What's really interesting is I've already started working with customers who are using these services and then sending all this data back into their data lake and then powering their quick sites or their tableaus or other BI tools under the covers with this data as they're bringing it into their system. So it really fits into those pipelines really, really well. These are various domains within the service. So you could pick, a retail domain, web traffic metrics. If you actually don't fit in any of these domains, you can use custom and still provide additional metadata for it to use as it's building the model. So I wouldn't be concerned if you have to use custom, but if you do fit into one of the other domains, there's domain-specific metadata fields you could specify that the service will use. For example, a workforce headcount for the workforce domain, that sort of thing. So I'm actually going to skip ahead a little bit. The other thing I'll mention before diving into the demo is what the service does is it actually doesn't necessarily give you a single point forecast. So if you're predicting the amount of electricity being used every hour for the next 2 days, it's actually going to give you a probability range. And that range is really important. It gives you that confidence interval. It tells you how well that algorithm is really understanding the fit of that. So you can look at the single P50 score, the median score, but you could also look at the various ranges of like the P10 to the P90 to get your 80% confidence, that sort of thing, to be able to get that probabilistic aspect within the forecast range. Various algorithms, you'll notice there's actually, kind of traditional algorithms like moving average and those sorts of things, as well as deep learning algorithms under the covers like DeepAR and MQRNN are both deep learning algorithms. So it has a mix of algorithms under the covers because really with forecasting, one algorithm isn't going to do the best job for all of them. It really depends on your data and what you're trying to forecast there. So I'm going to actually switch over to the demo and show this last demo here of forecast. And we're actually diving into the demo here. So this is bringing up forecast now. And what I'm going to show here is within forecast, you'll notice a similar set of constructs, right? Bringing in your data, building predictors, generating forecasts. I won't necessarily step through each of these phases again. One of the things I will show in the data sets, though, is the ability to actually have related time series data sets. So you could actually have multiple time series in your target time series, but then you could also have related time series data sets that may not be the target domain, but the service will find correlations to the target domain when it's building those forecast models. You also have the item metadata for the various items that are being forecasted. So if I'm trying to predict how many flights are going to get delayed, if it's a prop plane, it's going to get delayed by weather a lot more severely than if it's a jet, those sorts of things. So those sorts of metadata fields aren't changing over time, but help describe the items that are being predicted upon by the forecast model. So let's go ahead and show some of the forecasting. And what this is this is actually an electricity data set. And it's actually for various clients. And I'm going to happen to pick a deep AR algorithm here. I could have used AutoML and had it pick the algorithm that it found fit the best. And what we're going to do is we're actually going to pick a time range here. And we're going to say, okay, we want to forecast every hour for this client how much utility is being used. And one of the things you'll notice is this client is very, very spiky, right? A couple of the other clients that I'm going to show in a moment aren't as spiky. And the different values you see up there are actually those ranges. So that the P90 is the 90% up until that point. And then you see the P50. In the data set, I'm going to show a Jupyter notebook here in a minute, in a very quick minute, because I have 5 more minutes here. That allows you to be able to also get a lot of this other data out if you're interacting with this programmatically. All these services have the programmatic interfaces as well. But let me show a couple of additional examples, because just so the folks here get a flavor of things. So if I actually pick a different one, you'll notice a little less spiky, right? So you kind of see a little bit more of this rather than some big spikes, that sort of thing. We could also go in and pick another client here. And what's interesting is about this client, this is one model that we built with all these different time series in it in the service. So these aren't all custom models. We've built one model. We've provided all the time series in that model, and it's built this for us. But in this example, you'll notice 2 big spikes, some a little bit less activity, 2 big spikes. And the service recognized that and lets me then build this. And you could take this information, you could feed it into your website, you could then feed it into things like anomaly detection. There's a lot of different use cases that you then pull this data and then drive your forecast models for your different use cases for. So I'm actually going to show one more element here. And it's really going to be showing within a Jupyter environment some of what this looks like under the covers. And let me get rid of a couple of my tabs here. Let me go back over here. Looks like my connectivity is. I'll bring it up this way. So what we're showing here is I'm actually launching into the console. And I'm going to go into SageMaker now. And Pedro in the next section is going to go, in a couple sessions from now, is going to go into a lot of different features into SageMaker. But I'm actually going to be showing a particular notebook. And in this notebook here, we're actually going to show what this looks like here. And we're going to launch up this Python environment here. And the thing that you do within these environments is this is actually hitting Textract, even though I'm doing it programmatically. So you'll notice things like the schema definition, like you saw earlier. You could do all this programmatically as well. So here's all the different schema informations. This has multiple values like submetering and voltages and that information. All that becomes information that the service could use to build that model. And then ultimately what you could do also is after you built the model and you want to integrate it into your systems, is you can actually then take all that information out and get all this score information programmatically and send it to your various systems. So it doesn't have to be all through the console. We just were demonstrating that at the very beginning. So let's go ahead and switch back. I know I only have 2 more minutes. I'd love to dive a little bit more into all the code in those different pieces, but what we're really talking about is how to use these different services to be able to build these various solutions, to be able to extract content out of images, do natural language processing, be able to build forecasting and personalization, those sorts of capabilities. And it's all through those single lines of code, right? You can customize many of these services and interact with them through these simple interfaces to get these intelligent capabilities in your system. In fact, I worked with many customers where they've built end-to-end solutions within a matter of weeks and months, adding these intelligent capabilities in their solution. So very, very powerful to be able to do that and extract that information and bring that in. So definitely want to thank everyone for their time.